Hello everyone, I am Karthik Mansali. Welcome to my YouTube channel MK Maths. In last class we have studied about empty relation. So empty relation and some example we have studied. If you not watched that video, you can check my description that I have given a previous video links, so you can watch there. So now today we are going to discuss about a universal relation. So this is a second type of relation in trivial relations. So in trivial relations we have a two in trivial relations we have two types, that is a empty relation and universal relation. In previous video we have already discussed about empty relation. Today now I am going to explain about universal relation. So let's start with the definition. If R is said to be universal relation in set A. So here R is said to be universal relation in set A, then the condition it should satisfy each element of A is related to every element of A. So universal relation means here we have mentioned the keyword each element of A. In empty relation we have used no. In the place of each we have used no. So in the place of now we are using each. So each element of A is related to every element of A. It means, so if we consider a set A, in that every element of A, if each and every element of A should relate to every other elements in A. So in empty relation there is no element of A is related to every element of A. There is no relationship between any two elements of A. Here every two elements having a relation, so that relation we call it as a universal relation. So if each and every element of A has related to every element of remaining elements in A, then that R will become A cross A total, because A cross A is a Cartesian product. This A cross A is Cartesian product. We already know this A cross A is Cartesian product, and this Cartesian product is nothing but all possible relations. Cartesian product is nothing but all possible relations. So it means A cross A means A cross A contains all possible relations. So A cross A is a subset of A cross A. We already know set is a subset to itself. In similarly A cross A is a subset to A cross A. Then R is a universal relation. So there is slightly difference between empty set and universal set is, in empty set we use the word no element of A is related to every element of A. Here in universal set we use the word each element of A is related to every element of A. Each element of A means at particular how many elements are present in A. Each and every element should relate to itself, then that relation will be universal relation. So let us understand further with example. So here in example I have considered two examples. One is a general example and another is a mathematical example. So first I have considered a boys school. Same boys in a empty relation also we have considered same example, so I have kept the same example for universal relation also. So in boys school I have considered 10th class students. So 10th we are focusing only on 10th class students. The relation is height of any two students, heights of any two students greater than 3 feet. So here relation is we have to consider two students. We have to see those two students height must be greater than 3 feet. Obviously every student, if a student is from 10th class means obviously each and every student in that class will be greater than 3 feet. Nobody will be height of 3 feet. So if we consider this relation is working with this given condition, it works here. So this relation height of any two student is greater than 3 feet relation exactly clearly working with given condition boys school. So then this relation is R. So this relation we can call it as A cross A, means it is total Cartesian product A cross A. So this R is universal relation. relation. If we consider this boys school as a 10th class students are A, then R will become A cross A, because each and every student will be greater than 3 feet of height. So universal relation will automatically universal relation will satisfy. If we consider in mathematics same, I consider A equals to 1, 2, 3. Okay, same set A I have considered 1, 2, 3. Now I try to create a R. So I have to create a R, so that it should be universal relation. Okay, universal relation. It should be universal relation. So here definition, the universal relation definition says each element of A means it can be 1, it can be 2, it can be 3. We have to consider each every element of A means we have to consider 1, we have to consider 2, and we have to consider this 3 also. Okay, so first I am considering this 1 is related to 1. So this 1 is related to 1, so I am writing it as 1 comma 1 order pair. Next, this 1 is related to 2, so I am writing it as 1 is related to 2, and this 1 is related to 3, here I am writing it as a 1 comma 3. Okay, so each element is related to every element of A. This is the definition. So each element means I have considered 1 is related to every element of A, means every elements of A are 1, 2, 3. So 1 is here, 1 is related to 1, and 1 is related to 2, and 1 is related to 3. Next I have to consider 2. So 2 is also element of A. So same in similar way, 2 is related to 1. 2 is, so here okay, 1, 2, 3. Okay, 2 is related to 1. Next 2 is related to 2. 2 is related to 2. Next 2 is related to 3. So 2 is related to 3. Okay, I hope you all understanding. So next now I consider 3, because definition says each element of A, so 3 also present in A, so I have considered 3. Same, 3 is related to 1, so I am writing it as 3 comma 1 and 3 comma 2, because 3 is related to 2, and next last 3 comma 3. 3 comma 3, 3 is related to 3. So total we have written all possible relations. So this total satisfies the definition each element of A is related to every element of A. This each elements of A is related to every element of A. Here then this R is nothing but a universal relation, because every element of A is also related to every element of A. Here the relation is clearly working for every elements of A. In empty relation, the relation is not working for any elements of A. So if relation is not working for a given set, then it is a null relation or empty relation. If a relation is clearly working for a given set A, then that relation will be universal relation. I hope you all understood this universal relation. In next video we are going to discuss about reflexive relation. Now we are shifting from trivial relations to non-trivial relations. Non-trivial relations we have reflexive relation, symmetric relation, transitive relation, equivalence relation. We are going to study one by one. So in next video let us understand the definition and examples of reflexive relation, because we can expect 3 marks from that topic: reflexive, symmetric, transitive, and equivalence relation. So we can expect 3 marks from PU board there. Okay, up to then, see you, bye bye.